Okay there, everyone. So, Chapter 10, Cleaning and Sanitization. So this is, again, probably one of the most recognizable and important parts of food safety. Uh, Basically, some people say that it is the most important factor in how safe food is in a premise, is how well staff clean and sanitize their utensils, workspaces, and themselves. It's important to know that cleaning and sanitizing are two different actions with different goals in mind, and that cleaners and sanitizers really shouldn't be mixed together because they'll interfere with each other and how they work. So, to start with, cleaning and sanitizing are, again, foundational to everything this program is building towards. While it may be one of the shortest chapters we have, it's also the most important, particularly in preventing cross-contamination. Cleaning refers to the act of physically removing the dirt and food residues and organic matter from the surface using soap and friction. So that's where we're going to lift up the dirt and remove the dirt, which then makes way for sanitizing, which, on the other hand, involves reducing the number of microorganisms by eliminating the harmful bacteria, viruses, and other pathogens that might kind of stick around. And that usually works by somehow killing or removing, by penetrating into the cell membrane or the virus or inactivating it in some way. So following correct cleaning sequence, you have to wash with detergent and friction and warm water. You have to rinse with clean water thoroughly, and then sanitize with warm water or chemical solutions to help meet the risk contamination low. Um, these chemical compounds have specific instructions, so you either have to mix, if you're using chlorine, which is one of the approved, it has to be mixed to 100 parts per million. And if you're going to use a quaternary ammonia, it needs to be 200 parts per million. Or you can use a factory-produced solution, which needs to be mixed to manufacturer's directions. You don't want to use regular household cleaners because they can't be tested and they'll leave residues. And iodine you can use at 25 parts per million, but again, that's rather expensive and is generally reserved for glass dishwashers. Cleaning should be done regularly and as needed to prevent the accumulation of food residues, grease, and debris on surfaces, equipment, and tools. Consistent cleaning can help to eliminate breeding grounds for pathogens, and it can ensure that the food preparation environment remains safe and sanitary all the time. There are, however, a few pieces of equipment or places in a preparation facility that will require a little bit more enhanced cleaning, and that you can do on like a weekly schedule or a monthly schedule. These are more like your hard to reach areas or your places where food isn't really going to be, but you want to make sure they do get clean from time to time to make sure pests can't live there. Time should be scheduled to disassemble, clean, and reassemble all of your equipment as much as the manufacturer guidelines will allow. An example of one that has to be done each use is a meat slicer, which has to be disassembled, run through the dishwasher, and then reassembled after each use. In some cases, a grill might need to be taken down once a week and run through the dishwasher. Your stove burners usually have to be taken apart and run through. Sometimes the drawers or the refrigeration drawers from equipment might need a thorough cleaning. Parts of your hood vents might need to be cleaned out. So it's important to make sure if something can be taken apart to clean, you should be doing it on a regularly scheduled basis. Again, we're getting into your chemical compounds and concentrations. So approved sanitizing compounds should be used in food premises and not unapproved regular household cleaners. Chlorine can be used if the concentration is a minimum, again, of 100 parts per million. And quaternary ammonia, which is that usually the pink stuff you get from to squirt into the bottle, should be used about 200 parts per million. And again, with iodine, it's usually just reserved for glass dishwashers because of the price point. 25 parts per million concentration because it is so concentrated. These compounds can be used as there are recognizable ways to measure the concentration, usually with test strips is the most convenient way, but there are others. And they have minimal negative health impacts. So if the residue is there, it won't be as devastating as if it was something like, for example, a Lysol, which does a very good job of disinfecting, but it also leaves a fairly dangerous residue on surfaces. So, general dishwashing practices for utensils and dishes. Before washing, it's important to scrape off all the food debris when it's needed and to pre-soak the dishes and utensils in a solution of warm water and maybe degreasing or a food-grade soap. This will make it easier to remove stuck-on food and will improve the overall cleaning effectiveness, leaving the utensils bright, shiny, and reducing the chance of cross-contamination. Soaking and washing it with suitable detergent removes grease, oils, and any other remaining food particles from the utensils. After washing your utensils, they should be thoroughly rinsed to remove any remaining particles or residues which may interact with the sanitizing compounds, which will then reduce the sanitizing efficiency. Again, they should never be mixed because the sanitizer will start to act on the soap in the water, and then the soap starts to get used up by the chlorine. They both get used up, and you're left with neither soap nor sanitizer and just messy water. Utensils should be sanitized with an approved chemical sanitizer like chlorine or quaternary ammonia mixed to, again, 100 or 200 parts per million respectively. This step kills any remaining microorganisms and ensures that the items are safe for reuse. Iodine is, again, used mainly for glasses but can be used for cutlery because it doesn't really leave as much film, so some people like that it gets it a little shinier. Chlorine-based sanitizing mixtures can be made mixing a small amount of chlorine to a bucket or spray bottle, and it should be mixed to about 100 parts per million, as I say. Quaternary ammonium is essentially the same, mixed to your manufacturer's instructions or 200 parts per million. To verify that concentration, you'll want to use test strips that can be bought at most restaurant supply stores. You should also be using your thermometers to verify that your dishwasher's water reaches the proper temperatures. For sanitizing, it'll be 82 degrees Celsius. And again, we'll cover that a little bit later once we get specifically to dishes. And when we're talking about your dishes, when we get to the drying phase, they should always be dried, air dried, not really used with a cloth. So when washing dishes, according to any method, whether it's a 2-compartment or 3-compartment method we're about to discuss, you want to make sure that they're air dry because the towels can recontaminate a dish by leaving little fibers, or if you used a towel somewhere else or left it on a counter, it can pick up pathogens and recontaminate the plate. So while drying the dishes, you should always air dry them, leaving them on a clean, dry, and well-ventilated rack, like a metal rack made of rods. You also want that rack to be made of non-absorbent material, so a plastic slotted rack or a metal wire rack are usually the best. Any cloths that you do use for polishing or quick jobs around the area, like cleaning down your surfaces, should be used only for that surface, and they should always be clean and in good repair. If there's any soil, they should be tossed into the nearest laundry bag or wherever it is you put plate things that need to be put through the laundry. So we're on to the dishwashing methods. If you're going to wash manually, there's a couple ways. We're going to start the 3-compartment sink is the most often used. You have to use that if you're going to be reusing dishes or sending things in and out of the kitchen. So it's the most effective method for manual dishwashing. So you use 3 separate sinks for washing, rinsing, and sanitizing of dishes. The first sink is warm water with soap, and you use friction to remove any dirt or debris. And then in the second sink, you dip the dishes in to rinse them thoroughly. You can run the water into the sink because you're not going to dilute the cleaner or sanitizer. This is just to get all the bubbles and all of the materials off of the dish. Your third sink is going to be your sanitizer, and that's the one you're going to have your chemical agent like your 100 parts per million chlorine or your 50 parts per million bleach, and you're going to sanitize the dish that way. You're going to leave it in there for about 5 seconds and then pull it out again, and then leave it to air dry. The 2-compartment sink is similar. People often do this step wrong. See, what a lot of people will do is they'll have a first sink with just water and then the second sink with soap and sanitizer, and that, as we just covered, doesn't really work well because the soap and the sanitizer end up using each other up. So what you want to do if you're using only single-use cutlery is in this two sink system, which is appropriate for that use and that use only. Again, that's if you're using single use items and you don't have any dishes being reused. The first sink will be used for washing, so you'll have your warm water and your soap, and then you'll scrub your dishes with friction in that sink, and then afterwards you'll move them over to the sanitizer sink. The first sink is also used for rinsing, so it's not as good. You can use a cloth to kind of wipe stuff off before moving it into the sanitizer sink to make sure that it's all clean. But effectively, it usually follows that process, where a first sink filled with warm, soapy water and friction is used to remove soil. The second sink is used for rinsing in hot water at the minimum 43 degrees Celsius temperature, mixed with the sanitizing solution of 100 part per million chlorine or 200 part per million or manufacturer spec of quaternary ammonia. So when you're sanitizing your dishes should be sanitized for at least 45 seconds, and the water should be at least 77 degrees Celsius. So we're going to go back to the previous slide for a second. You can rinse them in 43 degrees Celsius water, but it should be a minimum for sanitizer at 24 degrees. Optimally, you want your water to be around 77 degrees. Obviously, for hand washing, the water temperature is going to rise and fall as you're washing. But again, we have it here. So at minimum, you want to try to keep it around 77 degrees Celsius. You want 45 seconds. The chemicals in the water should be around 24 degrees Celsius so that the chemicals don't get evaporated and can still function. And again, your chlorine should be 100 parts per million and quaternary ammonia 200 parts or manufacturer instructions. And for your glass or utensils, you can use iodine at 25 parts per million because it is more concentrated. So there are two main types of dishwashers used in commercial kitchens. There are ones that use hot water for sanitizing, and then there's those who use chemicals for sanitizing. Each type has a specific requirement for water temperature and sanitizing agent concentration to make sure that they're effective, and that will depend on how they work, whether it be temperature or chemical. For both types, the dishwater temperature should be, again, 60 degrees, 71 degrees, up to the 77, somewhere in that range, to effectively remove the residues and grease and cut through everything. If you've ever tried washing dishes in cold water, it really doesn't work that well, so it should be around that 60 to 77. 71 is pretty good range. The main difference, though, comes from how hot the water has to be to sanitize. The final step of the sanitizing with hot water needs to be at least 82 degrees Celsius to kill off all bacteria. Now, if you remember, that's the same temperature you have to cook a whole chicken to. So 82 is generally the area where it's been determined that it's going to kill most of the bacteria present in most things. For chemical sanitizing dishwashers, the chemical used, such as chlorine or quaternary ammonia, have to be made, again, to those concentrations of 100 or 200 or manufacturer direction. And the mechanical dishwashers that are NSF certified for commercial use are exempt from that because they'll have their own special way of doing it and they've been certified. But again, for those, they'll have that little sticker that says NFS, National Sanitation Foundation, on it, and those have their own different specifications, but they have to meet an industry standard in order to be accepted. So all cleaning agents and sanitizers and chemicals used in the establishment should be mixed and applied in strict accordance with the manufacturer's instructions, especially those with directions concerning how concentrated they should be. This makes sure that they perform effectively and safely in food handling areas without leaving a residue behind, which could cause chemical contamination to the food. Also, regular cleaning and maintenance of dishwashing equipment is necessary, so make sure you're always taking your dishwasher apart and spraying out any parts that can be cleaned. And this is important just to make sure that it keeps functioning at peak efficiency and for longer periods of time. So just to wrap things up, cleaning and sanitizing are the most important parts of any food safety program, and properly removing dirt and residue followed by effective sanitizing helps to prevent the spread of pathogens to food environments.